subject CC Capstone course. Under Capstone course, we are going to learn operating system, and under operating system, today or right now, I am here to teach you CPU scheduling. We are knowing CPU scheduling, but just to revise it and to clear some misconception about CPU scheduling, I am right here to solve one GATE examination question of CPU scheduling. So let's solve the question, or let's go to the question. Consider three CPU intensive processes which require 10, 20, 30 time unit. So here 10, 20 and 30 are given as burst time of three processes. Let's say P1, P2, P3. Burst time are 10, 20, 30 unit, and they arrives at 0, 2 and 6 respectively. So arrival time is given 0, 2 and 6. How many context switches are needed if operating system implement SRTF algorithm? So SRTF is shortest remaining time first. And SRTF is preemptive scheduling algorithm. Process will be given priority according to their burst time. Process which has shortest burst time will be scheduled first according to SRTF algorithm. And what is context switching? When CPU undergoes from one process to another process, that process may go to running state to waiting state or running state to block state. Another process is scheduled on the CPU. That is called context switching. So we need to count number of context switching in SRTF scheduling algorithm for given data. So let's start. I am going to draw Gantt chart. At arrival time 0, only one process is there. With burst time, only one process, minimum burst time 10. Next process arrives at time t2. At time 2. At time 2, again process with minimum burst time is P1, so no context switch. At time 6, again new process arrives. I am keeping this process in ready queue. At time 6, all three processes are arrived, but minimum burst time again P1, so I am not going to context switch P1 up to 10. Now P1 has completed its task or its execution. Now at time 10, two processes are available, P2 and P3. Minimum burst time 20 among these both. So I am going to schedule P2, and this is first context switch. I am not preempting P2 because P2 is minimum at any cost. Now last but not least, P3. And to verify the Gantt chart, let's do one thing. Summation of burst time of all process. This is common sense actually. You all might be knowing this, but still must be equal to this. So our Gantt chart is correct. Our Gantt chart is not false. So how many context switch? First context switch, second context switch. And here we are assuming that only three processes are there in CPU, but practically there are number of processes. So after execution of P3 process, there might be another process to be scheduled, but we are not considering zeroth and last context switch. So total number of context switch equal to 2. That is our final answer. Hope you all understand. Thank you.